Good afternoon, blockchain developers. Hope your day is going well. Welcome back to our webinar, Solidity by example. Last week we looked at, we ended on constructors. So today we'll be looking at inheritance in Solidity. And yeah, so what we're going to look at today is just give me a second. Yeah, so as I was saying, we're looking at inheritance in Solidity. What this webinar today is going to cover is we're going to break down what inheritance is and why it's a superpower sort of for blockchain developers. We're going to cover the virtual and override, like what they mean and how to use them. And then we'll look at a demo, a live demo of code. And then I'll break it down line by line, try and explain, and then we'll interact with that contract. So if you can see my window here, I have created a file called inheritance. That's where I'm going to be putting the code. We'll start by basically doing some definitions of some key concepts regarding today's topic, inheritance. So number one, what is inheritance? Inheritance is a mechanism where a new contract, say the child or a derived contract, can acquire the properties, that is the state variables and functions of an existing contract, which is the parent or base contract. So if you remember last week we covered a bit of this. We looked at the inheritance of a child, and and then to further explain what inheritance does is it promotes code reusability, logical organization, and the ability to extend functionality without duplicating code. And we have some keywords like virtual and override. The virtual keyword is a modifier used in a base contract function. It signals that the function's behavior is intended to be replaced or customized by a function in the child contract. So a function must be marked virtual to be overridden. And then we have the override keyword. This one is a modifier used in the child contract function. It explicitly declares that that function is replacing the behavior of a virtual function from one of its parent contracts. And then we have a concept called multiple inheritance. That is the ability for a single contract to inherit from more than one parent contract. Solidity supports this, but it requires careful ordering. So you have to be careful when you're ordering the process of inheritance. Then we have linearization, that is the C3 linearization algorithm. So this is the process by which Solidity resolves a specific order for all parent contracts in an inheritance hierarchy. So this order determines which function is called when there are conflicts. The rule of thumb is parent contracts are searched from right to left in the inheritance list and in a depth-first manner. We'll explain this, or you'll see how this works as we dive into the demo. Yeah, so we can look at our example today. So to just set up a comment here just to show a picture, or I'll call it a graph of inheritance, to show you the way our contracts are supposed to inherit. Just making sure. Yeah, so yeah, this is it. I could just add, because I'm going to add a few more examples here. So F, yeah, so this is just basically, so we'll have a parent contract A, and it will have two children, contract B and then a contract C, and then contract B will have contract B will have two children, but contract E will only have, rather contract C will have only one child, which is E. Now all these are the grandchildren of contract A. And here when I press tab, you could see the completion. It already set up the first contract. Just making sure it's using the same keywords. So yeah, it's a virtual. Okay, so we just add a comment here to explain. as child contract. Making sure there are no warnings in the file. Okay. So let's start breaking it down. So yeah, from line 11, we've declared a new contract named A. So we've started the smart contract, which is a collection. So this is basically our parent contract, and it's or what we call the base contract in our inheritance example here. So all other contracts are eventually inheriting from this contract A here. And then we have a function in that contract. So foo is the name of the contract. Sorry, foo is the name of the function. We've made it public, so it's a visibility modifier. It means this function can be called from outside the function. Sorry, from outside the contract. For example, by a user, and also from within the contract and any derived contracts. Then we have a keyword there, pure. State mutability modifier. It promises that this function will neither read from nor write to the blockchain state. It only operates on its input parameters and then returns a value, which is a string A. And then, if you remember, we talked about virtual and override at the beginning. So the virtual here is a crucial keyword. Yeah. For inheritance, so it explicitly declares that the children contracts or child contracts are allowed to provide their own version of this function, overriding its default behavior. And then, yeah, returns string memory. We're specifying the data type that this function will send back when called. Here, of course, it's returning a string. The memory keyword specifies the data location for the returned string. For reference types like string, array, or structures or structs that are returned from a function, you must specify memory. And then, of course, return A. So that's the function's body, and it's a return statement. So when it's called, it will just simply return that value, which is a string, and it's literally the letter A. It's usually the default implementation for the or it's the default implementation of the foo function in contract A. Then we have the first child contract, which is contract B. So we've declared a new contract named B. Then is A is the inheritance keyword. It establishes that contract B is a child of contract A. This means that B automatically has access to all of A's public and internal functions and state variables. So to demonstrate single inheritance and function overriding, this is it. And then it has a function, also foo. The virtual is used again here to, even though B is overriding A's function, but we're using virtual again. It's basically, it marks its own version of it marks its own version as virtual. This allows for further inheritance. Future contract like f would override this function here, the last one we made, f would override b's version of the full function. And then now here you see the keyword override is brought in. So that keyword is mandatory. So it explicitly tells the compiler that let's say like it's aware that a function named foo already exists in one of the the parent contracts, which is A, and we are intentionally replacing its implementation with this new one. So the compiler will check if this is true and throw an error if you try to override a function that doesn't exist or isn't virtual. So if we let's say not put in the virtual keyword, or if the function didn't exist, it would throw an error. Then return B. So that is the new implementation for the full function within contract B. So when called on an instance of contract B, it will return B instead of A. And then we have the third child, no, the second one, not the third. The third contract C is A. So that's another contract that inherits from A, just like the previous one B did. So we've created a second separate branch in our inheritance hierarchy, showing that multiple children can inherit from the same parent. And here, remember, we're talking about contracts, not literal children. Then it also has, the same function, but it's so it's identical to the function in B, but it will return C, and it also overrides A, and is itself also virtual. And then contract D is B and then C. So we've declared a contract D. The syntax is B, C. That is multiple inheritance. So contract D inherits from both contract B and C. The order there, B, then C, is critically important for the C3 linearization algorithm. Then inside that contract there's a function, full, public, pure, override, B, C, return string memory, and then return super full. So override BC, because D inherits from two contracts that both have a full function, we must explicitly list all parent contracts that we are overriding. We cannot just use override alone. So this makes the code clear and safe. Then return superfull. The super syntax there is a special keyword that points to the next contract up in the inheritance hierarchy chain. So super full basically means call the full function from my immediate parent contracts. How it works, so due to the linearization of is B, C, the inheritance chain is resolved as A to B to C to D. The super call in D looks to the next contract in the chain, which is C. Therefore, C full is executed, meaning it will return C. I hope that's clear. And then we have a fifth one, contract E is CB. So it's another contract with multiple inheritance. The syntax is CB, that is the order of, you can see the order has changed. In the previous one it was B, C, but here it's CB compared to the previous contract. And then it has a function, foo again. So if you notice there, the order of the override parameters has also changed to match the new inheritance order. Yeah, this is required. And then it also returns superfoo. Now how it works is the linearization of for E is with, also for E with is C, B. So it's like it's A to C, then to B, then to E. The super call in E now looks to the next contract in the chain, which is B. Therefore, when B-foo is executed, it will be returning the letter B. So this demonstrates that the behavior changes based on the inheritance order. We'll be looking at all these results when we interact with the contract after breaking down. And then the last one, contract F is AB. So it inherits from both the base contract and a derived contract B, which itself is also inheriting from A. Yeah, I'll say that again. It's a contract that inherits from both the base contract A and the derived contract B, but contract B also inherits from A. So while the order is A then B, we must always list parents from the most base-like the most derived. A being the base, B being the derived from A. So it is more derived. Lifting is B, then A. So let's say if we switch this order and put B here and then A last, would cause a compilation error because it violates the linearization rule. Then a function again. So the function must override both A, the A foo, and then the B foo. Now how it works, so the linearization for F is A to B and then to F. The super call in F looks to the next contract in the chain, which is B. Therefore, when B foo is executed, returning B, it will return B. Even though A is the parent, B's implementation is used because it comes later in the chain. Yeah. So, in summary or conclusion, what this code example here that we've broken down does, it demonstrates the core mechanics of inheritance in Solidity. We have basic inheritance, how a child contract, which is B and C, inherits from a parent A. Then function overriding, how to use virtual and override to change functions behavior in a child contract, and then multiple inheritance and linearization. That's how Solidity defines which version of an overridden function to use when a contract has multiple parents. So that we've seen it in the contracts D, E, and F. So this is the most critical part basically of the example we've covered here. And then in summary, it also shows inheritance ordering, the importance of listing parents from the most base-like to the most derived. Yeah, so Now I think we can compile and then interact with it. Now, because this contract is purely, they're all pure functions, right? All these functions are pure. That means that there will be no data to input. It will only be just outputs. We'll be just calling to check outputs because they're all pure functions. So it's just about reading data. So let's compile and then interact and deploy. Expand this. Okay. So we've done the first contract A. Deploy that. Yeah, it's contract A that has been deployed first. And then now we should expect to see A, right? If we call this, it should return A. Yeah, exactly. And then if we deploy B, okay, I can close this for now and expand this B. I call it, that should return B. Yes. So it has overridden the A, right? Because contract B was overriding A. And we expect the same for contract C. Yeah. And then now, when we deploy contract D, we should expect, if we look at what contract D does from here, sorry, we should expect C because C is the rightmost, yeah. So let's deploy it. Oh, I deployed C again. D, deploy, call food. Should be C, and it is. Oh, you can see it here. Then if we deploy E, so okay, yeah, if you, for this one here, it has returned C, remember, because of order is B, C, C being the rightmost. Yeah, that's the better way to explain that. And then contract E, let's look at contract E. So it has returned B, right? And if you look at the inheritance order is C, B. So here B is the rightmost. Yeah. And then if we deploy the last contract F, before I hit, let's just check and see what we're expecting. It should be B. Yep, correct. So yeah, it returns B, it calls the superpower function to B's implementation. And what was B's implementation? Return B. So let me maybe just to play around, let's say we, in this case here, we put B first. Yeah, you can see there's an error already. Yeah, as immediately as that is. So, and then when you look at the compile error message, it says linearization of the inheritance graph impossible. Yeah. So it won't even let you, it's not a warning, it's an error. So anyway, yeah, that's it for today regarding inheritance in Solidity. Thank you for tuning in. Please like the video, subscribe to the channel, and share the video with your colleagues. We'll be back here tomorrow around the same time to look at shadowing inherited state variables. Yeah, so that's for tomorrow. Right. Have a blessed evening.